Hi, this is John again. I'm on Mock 1 and I'm now on task 3, so I'm going to start building a logic circuit. Okay, so as normal, I've got my breadboard here. As you've noticed, I've felt tipped some colours on it. This is to make it easier later on with knowing which is A, B and C inputs, just for my reference. Okay, first thing we need to do is limit the voltage to 5 volts from 9 on the battery, so we're going to use this chip here. Stick this in just here. The first one's going to be the input, the second one is going to be to ground, which I'm going to stick in now. That's a ground, and then the third line is going to be the output, which is now taking that 9 volt from the battery and turned it into 5. I have 3 chips on this circuit. I've got one which is NOT gates, AND gates, and then OR gates. So the first one we're going to stick in is the NOT. I've lined this up exactly how I want it for, so it's all colour coded, so I can use those later on. And get the thing in, that is. Come on. There we go. Second one's going to be AND gates. Just stick this just here. Again, it's just getting it in. Just press down. There we go. Awesome. And then finally, we have got an OR gate. Excuse me. Sorry, very fever for some reason. Let's see if I can get this in. It's a bit fiddly, this last one. Okay, excellent. So each gate is going to need power. So usually the first pin is the positive rail. I'll do all the positives first. There we go. Positives, and then the bottom left is the negative. This is the same on, not negative, I'm saying that again, it's ground. There we go. And another one. There's another short bit, there we go. Try and use small wires, this is going to get a bit complicated with wires going everywhere towards the end. Hey, what can you do? Okay, there we go. So that's all the chips powered up. So now basically we just need to start wiring it all up. So the first thing we're going to do is I'm going to wire in the first NOT gate. So on my drawing we've got A, which goes through a NOT gate to reverse its value. So the input here is, so I'm going to put green to green basically. The next one out is going to be the output from that gate. So once we've got a negative, we're going straight into a AND gate. So what I'm going to do is I'm going to hop it across, no, because that's not going to reach, a long one. There we go. So we're going to go across from that output and into our first AND gate, just there. Now this one wants to go in with a B negative, or B opposite maybe I should say. So blue is B, so I'm going to go blue to blue. There we go. The next one down from that again is going to be its output, where it's the input's being made opposite. And then we're going to go and match that to just here. So now that's one AND gate built. Okay, so we're going to make the next AND gate now. The middle AND gate is C. So we can take C just as it is naturally. and couple it with what have we got? And another A, and another opposite A through. So the A from the NOT output, which is this one. Where's that long enough? Let's use this one. The problem with this circuit, there's wires everywhere. So we're going to use the next AND gate down, so we're going to use this one here, and just under the green there. So that's our A negative, and we're going to match that up with a C standard. Long enough. That's the other AND gate. Come on. There we go. Okay, so we've got the first two AND gates built. Now both of these go straight into an OR gate. So I'm going to build that now. So that's the first output. Straight into this OR gate here. And that's the second output, also into the OR gate. There we go. Okay, so we've got two ANDs and one OR built. Right, let's build the final AND gate. The final AND gate is a B natural and a negative C. Okay, so we're going to go build a negative C first, so we'll jump across to this side now. There we go, that's our C. Turn our C opposite, so we can go here, and then we'll use the other side on the NANDs. And sorry, not NAND, very neat. And there we go, it's fine again. Okay. So that's our opposite C. Now we just need a natural B, so we can use this blue here because I used that as an input before. If I can find a piece of wire long enough to go over the top, so we're going to go from that blue there, which is B, into the AND. Perfect. If we can make this wire to stay, that is the point. Right, let's use a longer one. Into the blue there. There we go, that's got it. Okay, so natural B and negative C, or opposite C, sorry, in there. Right, okay, so we've got one more gate to build, and that is the final OR gate, which is going to be the output of the AND I've just built. With the output of the other OR gate just here. Okay, that is the circuit complete. So what we finally need to do is I'm going to use these long wires. I can basically just go through the colours here and match it to the ground or to the positive line, and that will give me my on or off inputs, and I'll deal with that in the next video. Okay, thank you. Hi, it's John again. We're just ready to start testing that logic circuit now. So we're going to go back to the circuit exactly as it was before. There we go. So to test the circuit, we're going to use a logic probe, which is this bad boy here. And these bits get plugged in to the ground line. Doesn't go in that hole for some reason, and the positive line. This gives the probe power. Once I've got the battery in, of course, always helps. So the battery goes into negative, the input here, there we go. So now we've got 5 volts coming out of here, that's powered up my probe, so we can start using it. What we need to do now is test the logic circuit. So I've got a logic circuit just off camera here. You can't actually see the numbers, I'll read them out as I'm going along. Which is telling me what to test. So the first one we need to do is all inputs are negative. So we will set that up. A off. B off. And red C. Stick it anywhere off. Okay, so according to our circuit, this should mean we have a high output. You see that? Yeah, red light on, high. Cool, that's correct. Now we're going to put C high, so this is C here. That's the positive line. This again should read high. There we go. That's high. Now what we're going to do is put C back, and then B is the one what wants to be high. So blue to positive line, and again we should have a reading of high. There we go, all working nicely. So that's first 3 done. Now we've got B and C high, which should give an output of high again. And there we go, spot on. Now we just want A high and the other 2 low. So we'll turn them round, low, and this one here, green, twist you around and to the high. This one should read low, so we're hoping for a green light, and there we go, we've got it low. And with the circuit so you can start seeing that. There we go, that's low. Okay, next one, we've got A high, B low, C high. So we're going to move C, which is this long one, across onto high. There we go, and we should have low again. Spot on. Now C's going to go back to low, and B's going to high. Oops, all come out, so we've got... There we go. So A and B are both high, C low, and that should give us a high output. Spot on. And the final test is A, B, C, all 3 high. 3 high, and we go for a low output. Awesome, which we've got there. So that shows that this circuit is working perfectly. Cool, thank you. Hi, I'm now going to make the circuit, which is a reduced down version of the last logic circuit I did. It's also going to have the outputs inverted. So although the table in the book is incorrect, as a lot of things in the book are unfortunately, the one on the internet is right, so I'll be using that. From that table I drew up a little Kerno table here, if you can see it. Kerno, however you say it anyway. So basically it worked out that it's going to be A and B negative plus AC. So that's basically a very simple circuit which we're going to do here. If you excuse my drawing in crayon. Okay, so here's the breadboard. I've moved down to the bottom because the breadboard is actually popping my chips out, which isn't good, but anyway, don't matter. So we've got NOT and OR gates again, so we're going to use all of them, but we're not really going to use that many. So first off, we want, basically we're going to go straight into an OR gate. So we don't actually need the NOT to start with. So this is just basically going to be A and C, both natural. So A is going to be green up here, into the first end, and then another nice long end will be, maybe not that one. Make it C. Let's go C into the first one because the wire's long enough, and then I'll put the I should put these a bit further closer, actually. I want to like that. There we go. And this can just move to that one. So that's the first AND gate. We've only got 2 AND gates, which is awesome. So the second one is going to be B, but through a NOT gate, and then natural A again, so there's two natural A's there. So first we'll deal with the NOT gate. We're going to go on the other side of the AND, I think. So we'll go, what's being reversed? B into that NOT there. Then we're going to go from the NOT gate which is there to the AND gate here. I'll leave that space so I can go straight from A across with a decent sized wire. There we go. So we'll go from A across there into the AND. There we go, that's that one sorted. So we're only actually using one NOT gate this time, two ANDs and one OR gate. So we're just going to use both of these outputs on the ANDs, which will give us the OR. I like using this bottom one as it's easy to find. And then the final one is, that's the output. Input with the OR. There we go. Simple as that, pretty quick one. Okay. What I'm going to do now is I'll test it while I'm here, may as well. Okay, so as we've got all that lined up, what we'll do first is check that all the gates are working as they're expected to. So we're going to do the same as we did on the last one, which is have A at 0, B at 1, and C also at 0. There we go. Now remember to plug the battery in. There we go. Excellent. All set, all done working. Okay, so the first one we're going to check is the NOT gate, nice and easy. So it should be B reversed. So if we look at B there, let's just see if we can actually. Okay, so we're going to go into that. It's coming in high and it is coming out low as it's expected to. Okay, so the first AND gate will be natural A with natural C. So they both should be coming out on low, low, low and low as well. There we go. The next one is going to be what we got, natural A and B reversed. So we've got natural A here, low, B, and that's been through the NOT gate, so it's also going to be low, so the output should really be low, shouldn't it, because it's an AND, so that's also low, and then two lows in the OR also make a low, so that's correct. Okay, so if we go through that table, we will start off now with everything being on low, so the output should also be low. That's correct. Now we're going to have C on 1, C on 1, which should also give us a low. There we go. Now we're going to have B on 1, so C's going back. We've actually just done that one, so I know what it's going to be, but anyway. We can still do it again. So we're going low again. There we go, low again. 3 done, so now we've got B and C both on high. This should also be low, which it is. Now we've got A high and the other two low. So low there. Low there, and then A is going to be high. Cool. Okay, so we've got this should be coming out high, which it is. Fantastic. Now we're going to have C high as well. Longer wire, yeah. Okay, so we've got A high, B low, C high, and we should also be high. Excellent, A high on that one too. Fantastic. So now we're going to have A and B high with C low. And this one should come out as low, which it has done. And then finally we're going to have all three high, which should also give us a high. There we go. Excellent. So it all works as expected and only using 4 gates, which is nice. Makes it a lot more simple on the circuiting, doesn't it? Cool. Thank you. Hi, it's John again. I'm still on task 3, and in this one I'm going to be building an SR latch. I'm going to be using a switch and a NAND gate. Well, 2 NAND gates, but 1 chip. So let's get on it. Angle sorted. Okay, brilliant. There we go. So I've already got the NAND in and powered up. That's pretty evident I can do that, so I don't really need to show you, I don't think. What we're going to do now is I'm going to install the switch into the circuit. So what we're going to do is the switch is going to be connected by 2 resistors, and it's also going to have a ground. So I'm going to put the ground wire in first, which you'll see why. This will be on the very first one. Okay, so we're going to get the switch and we're going to stick it right above where the ground is. It's a bit tight, but I need the space behind it, so there we go, so that's in there. Okay, let's see if we can, oops, popping my stuff out. I'll turn it around so you can see. Okay, excellent. So what we're going to need is, on the 2 ends of the switch, is going to be a 10k resistor to the positive rail, so we've got 1 there, and 1 just there. That's it. There we go. Okay, so that's the switch wired in. I'll get it that way around so you can still see what we're doing actually. Now we're going to wire in the NAND gate itself. So firstly, we're basically using 2 NAND gates. This one here. I'll use a small wire because it's easier. Hopefully, anyway. Sometimes easier, sometimes not. And there we go. So that's going to form one of the inputs to the NAND, and then the other one is going to come across from here. And we're going to go to the first input. Okay. So the way the SR latch works is the output's connected to the input on the other one. So the output is going to be the 3rd one here. So I'm going to put that straight into the input of this one. Then the output of this is going to go back as part of the input of the other one. This is basically how the circuit works. I'm not going to explain it now because I'll write it down. Once we plug this in, that's the circuit. There we go. Excellent. Cool. So now what we'll do is I'll put some power on it and then I'll show you it working. I'm going to, come on, there we go. What I'm also going to do is collect a small wire to the output because it's a bit fiddly to get things in there. So if I just do it here and connect it to that, you'll see it nicely. Zoom out a bit, play around with angles. There we go, alright. Get all of this in. Yeah, there you go. As you can see, that is on high. If I flick the switch, we go to low. So that's the circuit working. Now, you may think it'd be easier just to have the switch connected, but what the NAND gates are doing there is basically stopping the switch from bouncing, because that's what can happen. As you switch it, it goes on off like that really quickly. You can't actually physically see it, but it's happening. With this circuit set up like this, that stops it from happening. So that's exactly why we're doing it. I think this is then going to be connected to a counter on the next one, so I'll turn this off and get on with that. Thank you. Hey, me again. I'm going to finish task 3 now by making the counting circuit. So we've still got the bounce circuit set up from before. What we're using here is 2 JK flip-flop chips, here and here, and an AND gate, and we're basically going to make a circuit which is a basic binary counter. I've connected all the powers to all of these, so I don't have to bother doing that, because it's wasted a bit of time. Right, what we're going to do now is set the circuit up. Okay, so first thing we need to do, J and K have power straight from the rails. So we're going to use this chip here. I'm just going to look at my pin out on my computer. So we're going to have, this is J, so that's going to have positive. And then K is also going to have positive, which the K is just here. I've connected both sets of rails to positive and ground now for ease as well. We're going to have a clock, so we're going to bring a debouncer in. So it's going to go from here into this one, so that's going to be our clock. Also on these circuits, they have a clear line which needs to be connected to the positive 2, or else the chip won't operate at all. I found that out after a great deal of wasted time, but never mind. Okay, so that's all sorted. This is going to have an output. The output of this is going to feed into JK, and it's going to go into the AND gate. So the output is the third one down, which is here, which is going to go into the JK of the next switch. So the K is the bottom one here, like so. Let's see if you can see that, it's gone quite dark today. What I'm going to do is to feed it into J. I'm going to just push it back across here. It'll have the same effect, so no worries. Sometimes I'm getting them right. Okay, there we go. And I'm also going to collect this one's clear. So there, live there. This also needs a clock, because you need the clock to switch, or else it won't operate at all. There we go. Okay, so here we have JK both inputted on the second chip. So the output is going to be this one here, and that goes to an AND gate. I believe the other output from the first one also goes to the very same AND gate, just here. There we go. These now both feed into the JK of the next circuit. So J is here. That wants to feed into K as well. I'm running out of wire. That's K. We need a clock, so I'm going to take the clock straight from the other one to the clock, and then the last thing we need to do is we need to connect it to the clear up. Okay, there we go. So that is all sorted. Let's connect the battery. Same as normal, into the 5-volt regulator. There we go, we're in there. Cool, excellent. Okay, so power's on. Let's see. Hey, how's it going? It's time to finish off the task 3 by just analysing the binary counting circuit I've just made. So here it is, still set up as before. So what happens is we've got 3 outputs. That's the first one, which is currently low, the second one, which is currently low, and the third one, which is currently low. The first one represents 1s, the second one represents 2s, and the third one represents 4, so therefore we can basic binary counting up to 7. So we're on 0 at the moment. If I flick it once, that activates the counter. So now we've got 1, 2 is still nothing, and our 4s are still nothing, so it's 1. Flick it again, this should have gone off. Yep, the 2s have come on, so 2, and the 4 is still off. If we flick it again, now we should have 3, so yep, 1 plus 2 is 3, and there's no 4, so we've got 3. So now we've got 4, so the first and second there should be nothing, so off, and then 4 on its own, so we've got 4. Now we're going up to 5, so 1 plus nothing, 1 plus 4 equals 5, excellent. Now we're on 6, so we've got nothing on 1, but we've got a 2 plus 4 equals 6, and then our final one's 7, 1 plus 2 plus 4, we've got 7. Okay, so that's the maximum of the counter. If we flick it again, it should reset back to 0 value. So we've got 0, 0, 0. So basically you can count up to 7 in binary. There we go, that's the circuit all working. And that's it. Thank you.